Okay, I think we're good. Oops. um, Welcome to another stream of OS Dev Gardening where I embarrass myself on the internet live as I attempt to work on an operating system. Yeah, welcome back. This is our third stream, third stream live so far. And today we're going to keep working on the build system, which is what has been the focus for the last couple weeks, because that's just such a fundamental part of the project, and it's just in such a poor state, basically. So if you're kind of new here, I am not making an operating system from scratch, but I just copied this open source one called XV6, and I've just been trying to work on it. And that's what I mean by working on an OS, not starting one from scratch. And yeah, the build system is in kind of a bad state. What I mean by that is, for the last amount of time, we've been focusing on trying to get the directory structure a bit cleaner. So previously, just all of the kernel files were in the root directory, all the user space files were in the root directory, and we've done a little bit of work, and now we have a kernel directory with a bunch of the kernel stuff, but still kind of messy. I did a bit of work in the meantime. I will actually be away for the next couple weeks, so I've kind of queued up a couple streams for the next 3 weeks, and so in those streams I was working on some out of tree build stuff, and also just continuing to kind of work on the build system. And yeah, here's what we have so far. So I'm just checking the OBS to make sure it's all good and set. Yeah. Yeah, so what we have so far is we actually do have a build directory that we've created. So this is recent work, and this is pretty standard stuff in modern projects, modern like C++ or C or most languages where you are building things. The build artifacts don't go directly into the source tree, but just go into this separate builder. And it was a bit of hacking to get to this point, but we got there, and we have some pretty clear next steps, because right now it's in kind of a weird place where some of the kernel objects are put in the build directory, but not all of them yet. There's all this boot block. There's this boot block thing, init code, init code .out, init code. I don't even know what the difference between init code .out and init code is. Entry other for some reason, boot block other. Don't know what that is, but that shouldn't be here. That should all be in the build directory. So I think we're just going to work on that today. Just checking in on here's our project management kind of board, and here's what we're focusing on. We're just focusing on this kind of cleaner create directory structure, and then I decided to kind of work on this out of tree build thing. Let's just jump into it. Yep, just checking. Okay. Okay, so yeah, I'm just also going to clean up some of this junk while we are here. We don't need. Yeah, this is just a bit of junk that's not too important. Stage that and amend into the whip commit. Good. Then here I just added this little target alias, which I'm like a little bit reconsidering. But yeah. So here's how this works. So we have this kernel, and the kernel is this, the kernel right now is just this string with the builder appended, prefixed in front of it. And then we prefix in a bunch of other places. We have this build objects thing, which is these kernel objects that have been prefixed with the builder. You can also get rid of this thing. Yeah. Yep. Okay. Yeah, so now we need to move our attention to all of these dependencies of the kernel. Let's just go one by one. That's probably a reasonable approach to it. Let's start with the, I don't know, the init code. Init code.other. What? Init code.out. What is that even? Who makes this? Init code does. For starters, what is the init code even? Initial process execs init. This code runs in user space. Interesting. So this is user space code. Zero. It does an exec. So maybe, this code runs in user space start. Oh. Initial process execs. Okay, this is weird. It's an infinite loop. Start. Syscall. Push argv. Yeah, I got to be honest, I'm a little bit confused with this file. It says this code runs in user space. So is this some really early code that that's how the init process runs? Like clearly it seems related to that. Push exec system call EAX. Yeah, it seems like it's assembly that is doing an exec system call and passing this string. I don't totally know why this exists. We can probably learn a bit more about it by seeing how it's used. So this ultimately compiles object copy. Yeah, this is a bit esoteric, I guess, or I'm just not experienced enough. But it's linked into the kernel. And if we want to actually understand this, we can probably go to main.c. User init. Set up first user process. Init code start. Init user space VM, possibly. Init code size. What is this? Extern char. Binary init code start. Beginning of init code dot s. It's some kind of code that gets mapped. This is, wow. Setting up a bunch of segment descriptors and stuff like that. Then just does some process state stuff. But yeah, I'm already kind of confused because I don't see any other references to extern char. Is it proc.h? Init code? Load the init code into address 0 of page 3. Size must be less than a page. It's like a bunch of raw code that's somehow compiled. I'm, kind of interested in this. Oops. So we have it's a blob of init code, and it really is what it says on the tin. Yeah, it just has a bunch of, it has two function looking kind of things. A start and an exit infinite loop. And then I don't know it. Oh yeah, then this is incorrect. This is incorrect disassembly, because if we go into our initcode.s, we can see that actually it's data, I believe. It's just argv and init. Mustafa, hello. Thanks for joining. Great to have you. Yeah, we're just working on a bit of operating systems stuff here. Yeah. Yeah, we have a bit of assembly going on for the init code, and we started down this whole path because I was trying to figure out the build system and understand these. There's a few dependencies of the kernel target, that's init code and entry other. And it's a little bit esoteric. Someone retweet your post. So here I am. Oh, sick. I think that must have been Mr. Ombre, who I don't know too much about, but cool. I followed you right back. Thank you. Yeah, it's this init code. And it's this blob of assembly that we build into initcode.o, and then we link, 20-second break. 20-second break timer. Get some water. Right. I have to totally be honest that I don't know what's going on with this linker thing. Maybe that's just what you need to do. You get an object file, but then you need to object files are not really usable in themselves. They need to be linked to something else. So you need to link it or something like that. And then then it creates this initcode.out thing. You know, maybe one thing I could do is I could maybe look up the xv6 manual or whatever and see, and they could probably tell me about this, but I kind of don't want to do that because I want to figure it out by myself. I am sort of, okay, I think this line is optional, but the obj copy is not optional. Maybe I'll just ask ChatGPT what these lines do. I'm leaning more and more heavily on ChatGPT these days as I get into just things I just like really do not know. What do these lines of a makefile do in particular? In particular, what do the LD and obj copy lines do? Whoa, what was that? Was that a subscriber or something like that? Oh, hell yeah. Just subscribed. Thank you so much. It's got the little sound effect happened. That's cool. Okay, so nice. ChatGPT is being quite verbose here. This generates init code. Linking command. Okay. This is actually helpful. -n, if it's true, which I hope it is, sets the output format to be oh magic, making the text section writable. Sets the entry point to start. So it's okay. It's an elf file with an entry point and everything. Specifies that it should be loaded in memory at address 0. Okay. So initcode.out is really like some kind of executable. And then object copy. I never have fully understood object copy super well. Translate into different formats. Okay. Strip out symbol and relocation information. Okay, just real quick. So this for like a file init code. Right. Init code.o is an elf object file. Initcode.out is really a elf executable. Plain init code file. It says it's zlib compressed data. Is that true? Wow. Who did that? Did obj do that? Is that even right? XD init code. What happened? Why is it all colored and weird? I've never seen XXD do that. Don't do that. Don't out color. This is the first time in my life I've seen XXD generate colored output. I think the file command is completely wrong here. Yeah, it's completely wrong here because we are generating a binary blob. I think with literally even no header, it's pure binary. And there's no header, but the file command is going to look and try to find some magic bytes at the start of the file, and therefore it's getting totally confused. So it's totally a red herring, or it's just totally wrong that it's zlib compressed. It's not zlib compressed at all, actually. And so what has happened for some, yeah. Okay, initcode.out is not really necessary, but in the end, but we need to apparently at least link something first and transform the object file into some like actually kind of proper elf file, because the .o file is not complete or usable just by itself. And then, but it turns out for some reason we don't actually want a full elf file. For some reason, who knows, maybe like we don't want to bother with loading an elf file. Maybe we just want really a binary blob that we can like memcopy into memory and like jump to or something like that. So for whatever reason, which I don't know yet, that's what's happening. Okay. So we just do this kind of like object copy conversion to like kind of a different format. We also strip it, and we produce our final init code. And yeah, so now I understand the init code a bit better. And I mean, I don't, it's just a little bit of code. It's like, this is like the first user space code that executes something like that. Because we're in the kernel main is here, and we do a bunch of stuff, and basically the final thing we do is we call user init and set up the first user process. And you know, as kind of as somebody that doesn't have a lot of experience with this, I just kind of assumed that the kernel would exec, yeah, it's going to exec like /sbin/init or just some hard-coded binary. But I guess I've never concretely thought about how it would do this. I just assumed, I guess it would load the elf like it does any other elf. But I think this is one of those things where it's actually easier to trigger certain things from user space than doing them all internally in the kernel. And like, for instance, the kernel already has a bunch of code written in the exec syscall for loading a program from disk and executing it. And so from one perspective, it would actually be kind of nice to just reuse that infrastructure rather than trying to kind of do that also in, like, maybe you could also try to do that in the kernel code and just kind of reuse the same helper functions and stuff like that. But it seems like another approach is just to have a really minimal user space like piece of code that triggers an exec system call. And then you just reuse all of your existing exec system call infrastructure. And I am not experienced enough to know whether that's actually really clever and everyone does it like that, or it's not actually that clever and there's better ways of doing this. But I think I understand that a little bit better now. And so in turn, to really get user space going, we have this blob of code, and we compile it in a very special way such that it's extremely easy to load into memory. One thing I just want to quickly try is we can look at this init code. It's actually quite convenient that the build system is set up to generate this assembly that we can look at. It's also so annoying. XXD disable colors Mac. How do I, since when does XX, oh, maybe it's, okay, I don't know why it's all colored. It's like very new for me. Can I just do that? Okay, yeah. And this totally confirms it. So we can look at the disassembly. We can see we have a bunch of instructions, and they assemble to like these 64, 24, whatever. And we can see that that is exactly what's in here. And so we've really just purely generated a blob of machine code without any other kind of wrapping around it. There's no elf packaging it or anything like that. There's no header. It's literally just a buffer of machine code that we produce. And the reason we can do this is because this code has basically like very little dependencies or no dependencies, or maybe, yeah, this is totally wrong. It's funny that the disassembler interprets this as like an instruction, but it's actually the string like /init. There's a 90 there, which is like kind of interesting. So yeah, so basically what we're looking at is the most minimal possible way to trigger like a system call, basically. And I actually kind of see what's happening now, because this should never return. That's usually kind of a thing. Like the init system, when the kernel finishes initializing and executes the init system should never return. And like on Linux, if that happens, the kernel panics. Like it triggers a kernel panic. And so I kind of want to test. I mean, so what we're seeing here is basically like, I kind of get the comments now. It's like, okay, exec the init program. And then if for some reason that returns, go into a loop of just triggering the exit system call. Although I don't actually get why you would do that. It's just looping in user space, triggering the exec system call. So yeah, that's very interesting. I don't think that's actually strictly necessary, but it's kind of like, yeah, well, what are you going to do? Probably panic, I guess. But I mean, we can test this. Let's do a test. Let's make sure our environment is sourced. Make Kimu. Oh, what? Okay, what's going on? Makefile 6. I constantly just break the build. Obs. Oh, okay. Well, we are not currently in a place where we can run the kernel, unfortunately, because we are in this half-baked state. I'm just going to add a temp commit. Let's just get back. Oops. Let's get back to a place where we can build. Make Kimu. Yeah, by the way, for anybody watching the stream, glad to have you. Would love to hear from you if like what your experiences with OS development are, or what your interests are. Yeah, I would be very, very curious about that. Yeah. On my end, I'm just kind of an enthusiast about this stuff. And I've done a bit of Linux kernel stuff, but not like a lot. And I always wanted to start from scratch, or at least try something like that. So this is what I'm doing right now. Anyway, we have booted the system. So if I Interesting. If I tried to exit, the exec system call fails. That's kind of interesting. What I kind of want to do is okay. What happens if we just don't? What happens if we just forget to start user space, or forget to trigger the system? Yeah, the system call. This should be entertaining and funny. Make Kimu. Panic, init, exiting. Okay. Dang. Oops. So there is some mechanism that I don't understand. If curve proc equals init proc. Interesting. So this also detects, so the kernel also detects. Oh, I kind of see. Okay, so really what's going on here is the kernel has loaded this code into like this very minimal user space thing, and I guess it's a process. I guess the kernel really needed to create a process. That's what this init proc thing, even though it's like this very weird and kind of, yeah, okay, that makes sense. The kernel creates the first process. That's what happens. It creates the first process. It kind of like very roughly or like kind of like manually just like stuffs like a small amount of code in there and triggers execution of that code. And then the code, all it does is supposed to trigger an exec system call, which is supposed to kind of like hollow out the process, or maybe that's bad terminology, but like completely reset the process in terms of like everything and start executing this new thing. But yeah, what we're looking at is it's really what runs in the init process. And this thing sticks around also. What the process that was created to run this, yeah, it sticks around long term for the life of the system. Yeah, just checking in on the stream on Twitter. Yeah, so it sticks around for the life of the system. And it executes the thing. And so okay, so there is this guard here saying if the init process, which is represented by a struct, like a global struct even, some global data. Yeah. And yeah. So we can like somehow, I don't really know how this works. My proc, this is interesting. CPUs have like a process and something like my CPU. I don't know. I don't really get that. CPUs can keep track of, I don't know. I cannot claim to really understand this part very well, I think. But we can access whatever the current process is. All right, 20-second break. Stand up, stretch, get some water. All right. Yep. So just to wrap up that thought, the exec system call has error handling code in case the init process ever exits. The init process has error handling code to make sure to trigger and exit system call if the exec system, trigger the exit system call in case the exec system call ever returns, which it should not do. Or usually the exec system call does not return, but it's good to handle your errors. So that's why. So this is basically the error handling code. So, if like in C code, it would be something like int, I forget even, it's like int ret equals exec ve blah, 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 blah. And this is something you might do. And then like if ret, this should never happen. Handle it or something like that. If the exec system call fails for some reason. That's exactly what we're looking at there. And strictly speaking, it doesn't need to be in a loop. Like technically speaking, it's probably fine just to have a single call here, which is going to trigger this panic. But this is just kind of a pattern you see in like very low level programming, like firmware also, where it's like, okay, if this doesn't work, there is nothing else to do. So let's just like loop basically and just keep trying it, even though that should not really happen. Yeah. So that is interesting. And just like a little bit of a meta note, I always learn something when I do these streams, and it's, even though I didn't really intend to get into this like assembly code and like all this stuff today, it was relevant to our makefile building work that we wanted to do. And it's just kind of another, like a different interesting perspective on learning OS development, where it's like, rather than like writing all of this from scratch, which frankly I don't really have the skill to do, I am just kind of reading. I do have the skill to understand a code base and kind of figure it out. And actually that improves my knowledge a lot, because now, let's say the next time I want to actually write an operating system from scratch, I will have this context and this knowledge in mind of how at least one system does it. And it's always good to get that knowledge of how at least one system does it. Because in true reality, I have no idea how the Linux kernel does this. I just haven't read that code before. It's probably kind of complex and like hard to figure out too, exactly like what's going on. So this is kind of just a very nice minimal environment to learn the basic principles of this. And so I understand the approach. The downside is that you need to like have this kind of odd blob that you compile. Like, yeah, it might be kind of nice to not have to do that and just have the kernel code be able to just directly load the init process and make a process. But yeah, who knows? Nice. So yeah, so here we are again. Anyway, what were we doing? So now that I've reached like really full understanding of how this code works, I totally understand the syscall thing. Yeah, I haven't reached complete understanding of absolutely everything. So I understand the purpose of this blob. I understand roughly what the build is doing. What I don't totally understand is, so this init code gets linked into the kernel. Yeah, it gets linked into the kernel elf, the kernel executable. But this, we don't have too much. We just have like a start symbol. Is that actually it? Like init p align to. I don't really know assembly like syntax well enough. I think that exports the symbol maybe. We can even do an experiment. Can you quit? We can do i3 read elf. I always init code.o. So that's okay. So this is like one command we can use to learn about this stuff as a symbol table. Entry point. Symbol table. And what's more interesting is this out one. Single program header. Load at 0 virtual virtual address. Interesting that we still have all this debug stuff. And just a couple symbols. Data and start. We have some local symbols. Okay, the last thing we do is oh yeah, init code is just binary. So yeah. Interesting that these local symbols are still there, but I guess they're not stripped, or no, the stripping happens at this phase during the obj copy. I'm just going to, just because I'm curious, I'm just going to do an experiment code out 2 and i3 strip out 2. All right, well, before we do that, let's just read elf and then go to out to confirm that we have a bunch of these local symbols. And then we will strip, and we'll look again. Okay, there's no symbols at all. Okay, that does make kind of sense, because symbols aren't even really necessary for like statically compiled programs. Dynamic programs are a different story, but even a lot of symbols aren't necessary. So the symbols are mostly for debugging and whatnot. Anyway, so the question I'm trying to figure out is, how does this blob like interact with the rest of the kernel? And what I've learned so far is that this thing, binary init code start, somehow this gets populated or something like that. But it's very mysterious because there's no other references. Extern char. I don't know if there's some way. It's just the start and stuff, so. Start? Is this too much? Entry. Oh, it's probably in the linker script. Yeah, it's in the linker script. That's my guess. At least I have not confirmed this yet, but I am pretty. Or I don't know. But let's check out this makefile again. Kernel.ld, right? That's what that's exactly what we are looking at. be binary. I'm just going to ask ChatGPT what this thing does. Because I think the kernel is, what I don't understand is like this -b thing. Kernel linker script. Because I kind of thought that the kernel was an elf binary, not like a binary blob. Oh, this option tells the linker to treat the following input files as raw binary files. Normally, LD expects the input files to be in a format it understands. Right? Okay, that makes sense. That makes sense. All right, cool. Once again, hello to anyone watching the stream. It's great to have you. Thanks for tuning in. Feel free to message any questions or stuff in the chat. Happy to answer more about what I'm doing if you're curious. But yeah, I think I'm quite close to understanding this. Output format, output arch entry, start, link the kernel at some address, debugging, interesting, it kernel debugging infishing, S tab, I don't know, e-text, e-data, okay, yeah. Well, I actually don't see what I was looking for. I don't. So I think there must be some like implicit. This happens a couple times. This pattern happens a few times where okay, I think, is it possible that the linker will implicitly create a symbol called underscore binary entry with the file name underscore start and size? Is that possible? That would be very cool to learn. That would be very, yeah, okay, time to ask ChatGPT. I don't understand this C code. Possible that the linker LD ever automatically creates symbols that start with underscore binary also, and have the start and size? Mustafa, you're asking, where's the E3 to E5? Good question. Those are not released yet. Those will be coming out every single Sunday for the next 3 weeks because I need to be away and I won't be able to do this stream. And so those will be coming out. The E3, E4, no, the E3 to E5 will come out in the next 3 weeks. So we kind of jumped ahead to E6, episode 6. But yeah, those are not released yet. Thank you for asking, though. That's it. That's crazy. Here's how it works. Huh. Well, this is interesting. I really learned something today. I really learned something that you can pass binary blobs to the linker and it will automatically create symbols that you can use from your code if you use extern char that correspond to these binary blobs that you are using. It's not even part of the linker script. It's just, if you want to just embed binary data into your binary, it's like go crazy. I will support you in that endeavor. I'll support you. I will give you I'll give you symbols that you can declare as extern. That is very interesting. Personally, I did not know this. I have never needed to know this. Oh, interesting. And it points out a bug. The size is not what? The size is not a array. So I don't know if you really need to do that. Extern. Okay, I want to just do a quick Google of like LD binary symbol start size and see what kind of official documentation I can find about this. LD start? Nope. SOR, blah, 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 blah. It's not your binary, blah, 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 size is not an integer. It's an absolute address symbol. I have never heard of this. It's an absolute when disabling PIE or linking statically. That is a term I address symbol. Okay, well, I don't know. Maybe this doesn't matter. But that's very cool to know. And that completes the picture. That totally answers everything. Okay, I've successfully achieved full understanding of how this works. I kind of want, but what? This is so interesting. It's declared as an array. I guess I still don't quite get that, how to properly take that. Like, what's the actual proper way to declare the size rather than doing this quite strange thing? And I wish I could find the docs on that. I will spend like another minute on this. I'll do binary object symbol start end size. GNU LD manual. Oh, 20-second break. 20-second break. Get some water, stretch or whatever. Okay, and we're back. Yeah. Found this. dash B is input format. Binary input format, binary files. What? Oops. Binary. Okay, I don't know. This is not, turns out this information is not super easy to find. So, yeah, let's get back to it. Okay, so great. So now that I actually understand this, and that's the funny part about working on the build system, is that it kind of requires you to really understand the code base to work on the build system, even though it's kind of like the least, to some people it's like the least sexy work, least interesting work. It's kind of hard to understand the build system if you don't understand the actual code sometimes. So yeah. Okay. So that is our init code, and the kernel depends on it, on this specific thing. Kernel there. So I think okay. So what's the strategy? So the strategy we used somewhere. No, oops, I need to check back out to our temp branch. Yep, okay. So this is what we were doing. And in order to do this, I asked it to build, yeah, I declared this thing. Yeah, I'm just going to do things the dumb way and figure things out later. I'm going to copy the strategy we used elsewhere. It's code. And okay, so one thing that's just interesting, I was for a second considering whether we can reuse our existing build rules for compiling from C or from assembly, but we can't because this is like ultra special, I think. Or is it? I mean, it definitely uses this special process. What was the other .s file? Kern.s. There's a bunch of these other things, but for whatever reason, they did not require all this special attention. Like switch. Okay, and the reason, at least for switch, is because it is just a symbol that is supposed to get linked against C code. Entry though. Yeah, for the most part, these are all you can basically just think of these as functions that we've written in assembly instead of C, but they're going to get called from and used from the monolithic kernel image. But init code is totally different because the symbols in init code are never going to get called directly from the kernel. It's kind of just like data that the kernel deals with. And so that's why this is a bit special. I mean, the easiest, if I'm being just like really dumb, like builder, but yeah, it's, I mean, yeah, this is really being kind of stupid, but yeah, I do not love what I'm doing right now. So we just manually, is this really what happens? We just manually specify, how did we do this before? We generically specified that for any arbitrary okay, we did this kind of upfront thing first, where we advertise that we want this specific object file at this like path into the builder, and then we can like match that against a C file and compile against that C file to produce this thing, and therefore don't need to hard code all this stuff. I wish I knew how to make like a local variable. I'm gonna ask ChatGPT how to do that. File rule. Oh, hello. This is not really, I just want a variable. Okay, whatever. So let's just yank that, paste this. Right. So that's, now we're going to generate our object file into the same place. Oh, wait a sec. No, I can be so much smarter than that. I think, what is the syntax? I think that's the syntax. And also, I'm just gonna, I think this, yeah. That's where you're like, that's the thing, that's the dependency. I believe. There's a specific pattern we used elsewhere. It's like -C, -O, the output, then the thing. -C. Okay, so now then we're, okay. Yeah, then here's where I wish I want to just like, I want to take initcode.s and just, I don't want to retype initcode.o, especially this whole thing. I just want to do like a command. I just want to do a string substitution for that last part. I'm just going to ask ChatGPT. I have a makefile. Yo, is it, I'm not sure I'm going to say this right. Is it rootvig? 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 Nice to see you. Thanks for joining. We're just doing some operating systems development. Makefile rule like I want to have a variable containing this out. How can I do this? Oh, man, this is so useful. Oh, Shivang, what's up? Good to see you, Shivang. Yeah, we're back at it. Rootvig says, I want to test your web. I'm junior pen testing, cool. I want to test your web. I'm not sure what that means, to be honest. But that's super cool that you're into pen testing. I was also very interested in penetration testing at one point in my life. It's very interesting. It's a cool world. You can learn a lot about computers, and it's kind of satisfying to like break them. So, okay. Do you host any web? I do not. Join us. Do I host any web? No, I don't really host any web. I don't host too much web. Yeah. Okay. I'm just trying to figure out how to. Yeah, I'm kind of wasting time, I feel like. Yeah. I'm just gonna. That's KK. Yeah. I'm just gonna keep going. I'm just gonna boldly move forward. Init code. Oh. Oh no, wait, I am messing this up. Shit. Yeah, I need to substitute. I think I did this below. How do you do this? You specify a variable and some kind of pattern, and then you just say like what you want out of the end. Okay, I think I will optimize this all later, but yeah, for the moment, no dir init code dot o, right? Yeah. Okay, so where am I from? I live in Germany, actually, but I'm from like the New York area in the U.S. originally. Yeah, where are you from? Sounds like your name sounds a little like Indian. Okay, so we're trying to build this into the build directory / kernel directory. Yeah, okay. Then I think this is all kind of wrong. I had the init code, and now, okay, wait, no, what the hell? Oh, okay. starting from scratch. -c, -o, this thing, and then the lastly, this thing. That's what we have. Next, we're going to convert that O file into a .out file. I need to look at the git diff again. This line originally looked like this. All you do is you give it the out, and then you give it the .o file. Okay. Right? That's what we're doing. And then lastly, we obj copy from Chicago. Cool, nice. Chicago. I have a couple friends from the Chicago area. Okay, we're getting so close. Obj copy. Didn't save it yet. Right. So all you do is you give it the input, then the output, right? What happened to my Vim register? There we go. Yeah, this is so, I need to find a way to use variables better, but I just want to get this like working in some kind of way. So this is, now this part is totally optional. And code asm. All right, let's run this. Let's see, make clean. What? Okay, what is going on? Make clean. What? Wait, why my clean? Why is my clean rule? I can't even clean anymore. What is going on? Recursive? Do I need this? $164. What is going on? I don't know why I didn't have this problem before. Multiple target patterns. Sheesh. I'm just going to temp init code. What happened? This, I could have sworn everything was working. It's not this, is it? I could have sworn at some point I had this working. Make clean. This is wild. Recursive variable. What is going on? Maybe let me try something. Make clean. Make kernel. make clean, make kernel. Okay. Okay. I'm just catching up on the chat. What job title and company? I'm a software engineer. That's my job title. I work at a company called Ableton. We actually make musical instruments. Yeah. MS major in cybersecurity from ASU. Oh, sweet. ASU. A long time ago, I used to play CTF with some people on the Shellfish team. And a lot of them at the time were based in UC Santa Barbara. But I think a lot of them now are actually at ASU. So that's very cool. Right now, I am trying to get my build system to do out of tree builds. I want my object files and my executables to be in a build directory. And yeah, I don't want them to be next to my source files. And for some reason, like it seems broken. This is just annoying. Like it was definitely working. What does multiple target patterns mean? Oh, Okay, no, I need to get my shit sorted. But make kernel, I could have sworn make kernel was working. Yeah, this is embarrassing. How is it totally broken? What if I make file multiple target patterns? Not super helpful. All right, 20-second break. Okay, multiple target patterns. So apparently, man, multiple target patterns. That's a tough one. I have not seen that before. Oh, is it an indentation issue? That would be maybe the worst. Line 60. This Reddit thing is saying indentation. Did I miss an indentation? Multiple target patterns. Something super weird is going on because I was definitely able to build this earlier. Well, let's debug the build. So right now, here's what we know. We know that it works in this commit, and then it stops building in this commit. We know that I think this line is necessary. but this wasn't necessary a moment ago. Originally, it was like this. Right? Make clean. And it's like, make cannot even run even a little bit because of, it's this recursive variable or something like that, which I'm referencing here in build objects. Maybe I need this? I don't know. Super weird. What? What? No. Yeah, holy. That's, okay, that's embarrassing. Somehow there was this, yeah. The backslash at the end of this line was including this thing in the whole thing, so it was this long, weird, recursive variable. Okay. Garbage. All right. I'm going to discard changes. Now we're all the way at the top. And we're here. And make clean. That works. Make kernel. Oh, I can't do that. Okay. Kernel, make kernel. Ooh, okay, I think that worked actually. I think that actually worked. Man, I was kind of sweating a little bit there. Yo, anime texture, what's up? Namaste to you too. Thanks for joining. We're making great progress on some operating systems development. And let's just take a look at, I don't know. I'm actually kind of confused by all of, wait a sec. I'm actually kind of confused. Wait, no. Wait. False celebration. Slightly false celebration. I just got it working. This is dumb. I got it working at that original commit. I'm gonna drop that. Now let's go back to adders. All right. Now, okay, I was checked back out, kind of back in history. Things should not be working, but that was kind of stupid. So now we figure out how to do that. And this thing, I'm gonna remove that. Make clean. And now we're gonna add our kernel thing there. Make kernel, build. Okay, that's more what I'm expecting. I was trying to do a little fiber implementation. Oh, sick. Very cool. I am very interested in that kind of stuff, actually, like the whole fibers, user space threading kind of thing. If I'm understanding correctly, I believe fibers refers to user space threading, like kind of like what Go does, or I don't know what other things do, but yeah, that's cool. Because when you work on fibers and user space threading, you actually do a lot of the same kinds of programming that you do when you're writing an operating system, because you need to manually do all of the thread switch off yourself and manage the register contexts and stuff like that. No, okay, wait, so okay, no, I think we can do this. Boot block, no rule. Okay, that's easy. So this thing is now depending on init code. And, this is all kind of quite messy. I'm just trying to get it working, and then I'll come back later. make kernel. Okay, but now, wait a second, no, I'm getting too far ahead of myself. Make init code. Let's just test that. Fail error opening dependency file. Oh shit. Because the build directory is not created. Build. Make dir. Build. Okay, the error was that it couldn't write to this thing. And the way we were previously creating the build directory before is anytime you tried to build one of these .o files, we would make dir-p. This is kind of stupid. Yeah. Dir? Okay. I don't know if underscores are allowed in target names. Build dir, make dir-p. I don't know. This is just kind of awful, but okay. Builder. Nope. Oops. Yeah, here's where I embarrass myself on the internet writing makefiles. How did that not work? Build? What? Error, hello. Did that not run? What? Why did that not run? Make build? So maybe I just don't understand how anything works, but I could have sworn that putting something into the right there is stating a dependency, which should run before making a code, but it's not. All right. Well, that's very annoying. Okay, I'm just gonna keep hacking away blindly at this. Does it have to do with the positioning? Error ASDF. No, this isn't like not even running. This is not, what is going on? Make init code, hello, okay. I see, it was recursing. I need to put it here. I see, it was first recursing into the init code thing. I think I'll name this build dir. I think there was something about putting a pipe there was maybe idiomatic or something. Now it properly hits this error. Do this better. That's all I have the mental capacity for right now. Okay, great. Bypass context switching, limitations of kernel threads and user threads. I don't know much about kernel, but did you have to run kernel on virtual machine while developing? Yeah, that's what I'm using. I'm using Qemu, Qemu. My build is broken right now, so I can't, but I can go to my second checkout. Make Qemu. And so yeah, we're running in a virtual machine. Will Docker work? Docker is for running like Linux. It's like Docker images. I don't think Docker doesn't really seem like what we want for this, because Docker is very Linux specific. Yeah, it's very Linux specific. Yeah, I think other things are what you want, like Qemu or Box, B-O-C, SCH, something like that. But more importantly, our init code build. Let's check it out. Build, kern, init code sm.d, all this stuff is there. That was a long struggle to get to this point, unfortunately, but it's just because I don't know make that well. But we are well on our way. So now the init code builds. I'm gonna also just, I see, I'll put these two next to each other, and like the kernel one should be near here to keep that nice and tight. This thing should go probably a bit higher because it's just like very essential. Maybe up here. Init code. These are also quite essential things. I will clean it all up later. So now, here we got our init code dependency specified, and now we need to specify this annoyingly long path. Which I hate doing. I mean, the easy solution is just to declare a global variable. Builder / kernel, yep. It's to declare another global variable for the kernel's directory inside the builder's directory, but that sucks. It would be so much better to be able to like or what if we just directly, what is init code? Builder / oh, what? Builder / init code. So, actually, yeah, where should this init code thing go? Everything was just in the root directory previously, but the init code is like it's like a bit of an implementation detail of the kernel. I'm not really sure it should go. I think it actually should go. Okay. Okay, it should actually go. You know what? I'm just builder, kernel builder. Build underscore kernel dir. Build kernel dir. Oops. And then init code is going to be kernel dir. Yeah, this feels kind of dumb, but okay. Then, so now I'm going to go to every place where I did this thing, which is a lot of places. And I'm going to substitute that with build kernel dir. Except for actually, even right here, init code, the cool thing is that now I can just declare a dependency on init code. And I can similarly just say init code. I don't know if this is idiomatic or whatever, but I believe this will just work for now. So init code. Yep. And let's make clean and make kernel and see where this thing fails. Undefined reference. That means something did not get linked. Correctly. That's annoying. Does this file exist? The file does exist. The file does exist. Undefined reference to. All right, quick Twitter break, just to see who. I got some likes on my tweet about that I'm streaming. Very cool. All right, back to focus time. Why? Oh, damn. I think I know the answer. Man, this is awful. Control C, Control V from Willie. From Wiki. Yeah, sorry, Rujiv, I don't mean to ignore you, but I am probably not going to disclose my LinkedIn at the moment. But feel free to follow me on Twitter. I'm happy to chat there. All right, from the wiki. No, I know the problem. So the linker creates a symbol based on this string. Yeah, there's just something that's clearly so wrong with this. We should. We're spending all this time adding all these prefixes everywhere. Ideally, the search path would just be adjusted so we don't have to do that. All right, 20-second break. Stand up, stretch. All right. Yeah. Huh. Also, just a quick question for the chat. I'm kind of new to streaming, so I don't know how my audio is like in terms of volume level. I don't know if I'm like too quiet or too loud or not. So, would appreciate any feedback on that if you'd like to. Yeah. Okay. We need to. Hmm. This is annoying. That we really need to like cd into the build directory or something like that before we start running all this stuff. Can we do that? Is that a legitimate strategy? That actually will break a lot of stuff. But we might need to do that. I'm just gonna ask ChatGPT again, like what the plan, like can I cd and change directories in a makefile build rule? The change will not persist. Okay. What we need to do, this is kind of stupid. cd builder and do that. Yeah, this is becoming a total mess. But the problem is that even if we do that, our goal is that we need to somehow build this kernel. But init code needs to I don't love the idea of cding around everywhere in my like scripts. So we are in a bit of a dilemma actually, because apparently like what just okay, this is, what if I put an X there just for, oh, now I can't find, yeah, now it breaks, cding breaks absolutely everything. I feel like this is a little bit of a weird impasse. Okay. Wait a sec. Wait, let me nice one. Well done. Yeah. So I the kernel dir, if we cd to the builder, the linker script is not going to be in the builder. Where was the linker script again? What? Linker script is in the kernel dir. Maybe that's a bad place for it, to be honest. Maybe it should belong with the makefile in the root dir. That still doesn't really help this situation. Yeah. Man, this is, yeah. So what's the problem? The problem is that we're trying to build our kernel. We specify all these paths to object files, which it sort of sucks that they're all prefixed like this, but whatever. But then we need to specify these blob files, and the linker is then going to use them to generate these symbols. But now we've changed things. We've moved things around. We've moved things around. And then now that means we would need to, I don't even know how it handles slashes, but it would also mean we would need to change our code, which is like not good. I wonder if we can use the linker script for this. Maybe. But I kind of don't want to do that either. Is that really necessary? C++ 20 modules versus pre-compiled headers. Huh. Okay. Is there any easy solution to this problem? I feel like so the way CMake does it is that it completely emits the makefiles all into the build directory. Cannot open a linker script. Yeah, man, this is kind of weird. It's gonna focus a little bit. How do we? Is there anything we can do about this? It's frustrating that the init code file needs to maybe the linker script is how we need to do this. GNU LD linker script input format. Or maybe I'll ask ChatGPT. I have an LD command line that uses -b binary blob, and then in my C code I use extern char binary blob start. Is there a way to express that -b in the linker script instead? It's an option. to change. That's handled by the command line. Okay. Wait, what? Alpha object file. So it's telling us to create an object file. Create an object file. Once you have you can reference this object directly in your linker script or add it to your LD command line without needing the B option. Is that true? I think it's wrong. I think that's not correct. Yeah, I think it's kind of wrong. All right. Man. How do I compile my kernel while passing just the word init code here, basically? And so what if I run this command in the builder? That changes actually a lot of things, but I need to run this command. I need to do a few things. I need to copy the kernel LD into the builder. Whatever. We're just gonna hack this. We're gonna like completely cowboy hack this. Copy kernel dir kernel.ld into builder. Whatever. All right, copy the kernel LD into the builder. And then we cd into the builder, and then we run the linker. But we can't pass this build objects thing because it has the prefix. So we need to actually use this other variable, the regular objs, which I was planning to delete that, but I'm glad I didn't. How do I compile the kernel? Plato 300 BC. Yes, timeless quote. And then now, okay, so now this is kind of working. But there's a few other problems, and I'm just gonna hack the hell out of this. I'm gonna move. Oh man, this is actually the worst. I'm going to move kernel build kernel dir init code into build kernel dir. Ideally, we would not do this. Ideally, we would just like emit it into the right place, but we've already written like a lot of this code. Or maybe it's just this binary. Or maybe not. I don't know. Build kernel there. Okay, whatever. I'm just gonna move it one directory back. Then I also need to move entry other into the builder. Man. Okay. Then now I can cd into the builder, run the linker. It's going to find the kernel LD because we just moved it. We just copied it. It's going to get all the objects paths which don't have the builder. It's going to use the binary, and the init code is going to be there because we just moved it back one directory, and we also moved the entry other forward one place. Oh my gosh, the things I do. Make kernel. Okay, copy kernel. copy kernel, move, build current init code, build. What? Okay, what? Error, what? Make, oh shit. Make clean, make kernel. Okay. I actually, I'm a little bit confused why these move commands are not being printed. What? Does, or what? Is the white space a problem? Make clean, make kernel. Why isn't it, make clean, right? Build, there's no build. Make kernel. I'm so confused. Oop, make clean, make kernel. Right? Hello? Why did that run so early? Why does it run before all these regular commands? Why is the, okay, warning. Hello. It runs first for some reason. Why does that run first? That's so strange. Am I being like stupid? Like what? Move? What is in the build there? Nothing is there. Kern. Got our kernel.ld has been copied in here, which kind of sucks. I kind of don't love that actually. I'm actually just gonna not do that. I'm gonna copy it into, oops, the builder, and then now we're just gonna do kernel.ld make clean, make kernel. What? Build? Why did this command not work? Okay. So you're telling me if I run this command, it doesn't work? Am I doing something extremely stupid right now? Do I need a slash there? Oops. That's a file, right? So what is going on? Why? Okay, I am going to Google this error. Move are identical. I'm trying to move this WordPress thing into, I'm getting an error saying the files with the same name. Now this is embarrassing. How do I, like, I'm just trying to move a file one thing back. All right, 20 seconds. We'll attempt to move it there without changing the name of the file. I'm not trying to move it to a file that it's already in. I'm very much not trying to do that. Oh wait, I'm stupid. Yes I am. I'm being dumb. All right. This is the, yeah. All right, I think it's time. Yeah, brain's getting a little bit fried. But, okay. Build, can I output file? And now it's just gonna be called kernel. It's just gonna be called, all right, I think we're almost there. Yeah, it worked. It worked. Oh my gosh. Brutal, but we did it. And what did we even do? So now we have the init code moved into the build too. So now we have this nice, totally separated build directory. And yeah, I'm just gonna take a moment to whip get init code building in builder. This requires crazy hacks at the moment. The most annoying part is this linker implicit symbol that's generated for the binary blobs. We need to strictly pass the string init code to the linker, I believe, which means we need to run the linker in the same directory as these files. All right. Well, the stream, I want to end the stream. I need to head out, but I feel like we're kind of close with all this entry other stuff. Because is the entry other is the main other dependency of the kernel. And so that would be so sweet. And I think it's doing a similar thing as init code. So what if I just in fact, I think even, nope, never mind, a very similar, no, never mind. So first off, I think we can do this very quickly. Build kernel dir entry other .o. And that goes into what boot block other? What? This is weird. I completely do not get this. What is entry other anyway? Is it the entry for the other CPUs? IPI from the boot CPU. Wow. Boot is not entry to S. What's the deal with this boot block thing? Boot block other. Interesting. I'm just going to assume whatever. I'm not going to question it. I'm just going to assume that this is what needs to happen. Build kernel dir. Build kernel dir entry other. Although I think from what we just saw, that needs to not be there. That needs to actually be in the build dir. And then this is kind of optional, but we will humor it. Okay. So I think that means we can not do this. Oops. All right, make clean. Make entry other. Does that work? Oh, we're in the build. What the hell? Make entry other. Oh, okay, so the same stupid thing's happening, which means we need to build dir. Make entry other. Okay, I think that worked. I have an entry other there. All right, I think this is good. I think this is great. Make kernel. Yes, I think it worked. So now we have a totally nice and clean root dir, and everything is just in. Oh, that's not useful. Now everything is just in this build dir, and we have a nice separation of source files and other things. We still cannot boot the system yet, or can we actually? Now we just need to tell the xv6 image, although this should actually already know. Okay, maybe we can. Maybe I spoke too soon. Make Kimu. All right, let's go. Echo hello. We did it. We did it. So we're not completely there yet at a totally clean out of tree build. Because, okay, I mean, user space still completely builds in the root. and the boot block is still there. And I think there's supposed to be like an image file. Is that not real? Is that fake? Is that just not necessary? Like, what is going on? Apparently, no, it totally is. Has to be, right? Kimu, right? It literally ran this Kimu command line. Yeah, am I just blind? It's right there. Okay, yeah. All right, I think that's a great place to end the stream. We made a lot of progress on our out of tree build and learned a lot about this init code infrastructure in the process of how like user space starts in the OS. So that's super cool. I'm just going to quickly add another messy commit over here. Whip hack entry other into the builder also. Nice. All right, I think that's a good point to end the stream. Thanks for anyone that tuned in and still watching, and I'll see you next time. Actually, I'm away for 3 weeks, but I'll have videos uploading every Sunday at this time also. And I'll see you in a few weeks. All right, bye.